Why is that? What you want to know?
Actually, I thought I wrote some things, but I forget it to write. That's why.
Okay, well, no, what I'll do is I have recorded the entire class, yesterday's class, okay? So what I'll
Yeah.
do is I will upload it today on YouTube and I'll share the link with all of you so you can go back and see what we have done.
Okay, sir.
All right?
Okay, sir.
Okay, fine. So let's start the class today, the last class before your Durga Puja vacations. Okay, so if you have any problems related to what we have done, Ali, please can you mute your microphone? Okay, thank you very much. So if you have any problems with the previous classes, then I will, share the links of all the classes on YouTube, so you can go back and kind of go through those classes once again and clear your doubts. Even then, if you have any problems or any queries, then you can contact me. Okay, and we can discuss. So those students who have again joined late, I will be sharing the links of all the classes that we've had so far on YouTube. And just give me some time because I'm just processing the second part of the, this last week's classes. So once it's ready, I'll upload it on YouTube and I'll give it to you most probably by today evening or worst case tomorrow. Okay. Uh, so somebody is joining right now for the first class who is not, I think who has joined. Sahil Murmu. Who is Sahil Murmu? Okay, I am allowing you to join today from your outside network, but you will have to connect through your KIT email ID and then attend the classes. But for today's class, I'm allowing you because you have not yet received your user ID password. All right, fine. So what are we going to do today? So yesterday I told you about an operator called as a conditional operator. Okay, and I told you that that operator is special, right? I told you something about the conditional operator. Let's see whether you remember that or not. Conditional operator. What was so special about this operator? Do you remember from yesterday's class? This is a special operator. This is the only operator that takes 3 operands. Okay, this is the only operator which takes 3 operands. So how does the 3 operands fit into this conditional operator, and how or what is the meaning of this conditional operator? So let's have a look at that. So the general form of the conditional operator is this. Let's say X is an expression and here is a question mark, which is a part of the operator. Then we have Y is another expression, and then you have this colon, and then you have Z. So your conditional operator is made up of these 2 symbols, and the expressions are fit here, here, and here. And there has to be 3 expressions. The 3 expressions are nothing but those 3 operands. So the first, second, and the third operand fits here. Okay. Now, amongst these three, X contains the test condition. Y and Z represent the 2 possible final value of the expression. Okay. So X is basically, the test condition. Y and Z will represent the 2 possible final values of the expression. So if X evaluates to a non-zero, that means logically true. Okay, if X evaluates to a non-zero value, okay, so this is a condition. If it evaluates to a non-zero value, that means if it is logically true, then Y is chosen. Okay, then we choose Y. But if this becomes logically, if this becomes logically false, when does this become logically false? When the expression, that is this expression, the X evaluates to 0, then this is basically logically false. So what is chosen in this case? Z is chosen. So Y and Z are 2 different expressions which are chosen depending on what is the value of x that is evaluated. So this is a scenario where we have something like this. Okay, this is a scenario we have something like this. This is x, this is y, this is z. So this x basically specifies a condition here. Depending on this condition, either we take the path y or we take the path z. So if x is logically true, that means if x is not 0, then we take this path. If x is equal to 0, that means if it is, logically false, then we take this z path. Okay, so basically this is what this conditional operator does. So let me, give you a small example. Or I think rather than doing this example, I think I can give you this small assignment that you can actually do it in your class. You can try this logical expression in your class. Okay, so again, when we talk about x as a condition, right? Or let me give you an example so that you don't have any confusion, because otherwise you're going to forget. So I'm going to write a program, and I just follow this program, and then we will discuss the output, and we will see exactly how this conditional operator works. So we start with a normal hash include. Okay, so I'm just skipping this for now. So let's get into the main, and I'm just writing this int, and here we start writing a first line of code. Right, let's declare an integer, that's x. Okay, now since we've used the size of operator, let's try to bring that also into this. So let me use this size of int. All right, so let me use the size of int here. So everybody should be clear about what we are doing here. Whatever is the amount of bytes which are reserved for an integer by the compiler, the size of that is going to be calculated here, and that size is going to be put into or stored into an integer variable, which is x. All right, so what do we do next? Let's try to print this size, but with a condition. Okay, let's try to print this size with a condition. So I'm not writing the print statements here. Okay, but what I'm writing here is, suppose I want a value. Okay, let's go and write this so that I write the complete kind of sentence. Okay, so just give me a moment. Okay, so suppose I write this percentage d here. All right, so this percentage d, that means I need to specify a value here. Okay, so I need to specify some value here. The value should be an integer. Okay, the value should be an integer. Now, if I say, let me put that condition in now. All of you look at this very carefully. Now, x is an integer, and d is basically a format specifier for an integer. Now I am writing my conditional operator. What was the format of my conditional operator? The format of my conditional operator was something like this. If, right, this, which I had written. That means this condition, this is a condition. If this condition satisfies, then we execute y, otherwise we choose z. Okay, so same format I'm going to use here. So what I'm writing here is x equal to 2. Now this is my condition. So I'm going to get the size of my integer, and I'm checking here that is the size of an integer 2. Is the size of my integer 2? Right. Now, if the size of the integer is 2, that means the compiler which we are using is storing or allocating 2 bytes of storage for this integer. Then I'm going to put a condition here. Right? I'm going to put a condition here. The condition is, I'm going to print something. What am I going to print? I'm going to print, right? Let's say I print the value 1. Okay. Else, what I'm going to do, I'm going to print the value 0. And then let me close this entire expression and I close this loop. Okay, so if you look at this statement here, what I have done, what is going to get printed here? So if the size of the integer is calculated as 2 bytes, so x will have 2 bytes, right? So here, what we are doing here is we are checking what is the value of x. So in case the value of x is equal to 2, this will be printed as 1. If the x is not equal to 2, then we're going to have the value printed as 0. So if the compiler is allocating 4 bytes for an integer, then what will get printed? 0 will get printed. If the compiler is allocating 2 bytes for an integer, what is going to get printed? 1 is going to get printed. And what we have done here is basically used this expression in the format of, sorry, this part will not be, this will not be there, only this much. What we have done here is we have evaluated an expression using conditional operator. Okay, so conditional operator, what is the condition here? The condition is x is equal to 2. This is the condition. So if this condition satisfies, then choose 1. So this 1 is going to come here. If this condition does not get satisfied, then choose 0. Then 0 is going to come here. And both 1 and 0 are integers. So did you understand how we use these conditional expression? This conditional expression, this conditional operator, you can skip this conditional operator also. And in order to do this, you can use something as if then else statements. Okay, we have not yet studied this if then else, but we will be studying this very soon. So when we talk about if then else is a way by which we can do the same thing, but we can also use an operator to do if then else. So here the same thing is, if x is equal to 0, then do 1, else use 0. Okay, so if then else, what we're going to learn that in the future classes. Okay, so don't worry about this if you don't know what if then else is or what exactly it is. But for now, you just remember that this is the usage of your conditional operator. And the conditional operator, whatever work we are doing here, can also be done using if then else, which we are going to learn in the next class or classes which are going to come up after the puja vacations. So for today, for now, you just focus on the conditional operator. So x, y, z. This is the condition. These are the two options that you would choose depending on the condition. If x is true, or if it is satisfied, or if it is non-zero, then we choose y. If x is false, that means it is 0, then we choose z. So I hope everybody has understood this much for conditional operators.
While column
Yes.
Z is sir, why column Z? That is question mark.
Oh, sorry. I made a mistake. I'm sorry. Okay, I made a mistake. So it is actually this and this. Like here, look at the format here. I made a mistake. Sorry. So it's basically this and colon here, like this here. This is, I made a mistake here also. I'm sorry, guys. So please correct this if you have. This will be in a question mark, and this will be a colon. Okay, question mark and then a colon. So the format is x question mark y question mark. Oh, sorry, colon z. Okay, so here I made a mistake. That's sorry. So here let me just write it. Question and colon. Is that clear?
Yes, sir.
Okay, fine. Thank you for pointing that out. So basically, this is what the conditional operator is. The reason we are using the conditional operator is because we have already talked about the for statement. We have already talked about do while statement, and we've also looked at the while, and all of them involve a condition. Okay, so Just remember that these are conditional statements. So in this chapter, what we have done is we have looked at the size of operator. We also brought the size of operator here. We have seen the logical AND. We have seen the logical OR. We have also looked at the XOR, right? We have looked at the logical negation. And the most important part, which was there in this chapter, and one of the most important concepts in this chapter was we looked at the 6-bit manipulation operators. They are also called as the bitwise AND, bitwise OR, bitwise XOR, the bitwise complement, the right shift operator, and the left shift operator. And the conditional operator, why is it important? It's important because this is the only operator in C that can take 3 operands. And this is the typical question asked in your interviews. When you go for a job interview, or when you go for a higher education interview, or if somebody is trying to test your C skills, this is a very popular question where they can ask you, can you give me an example of an operator which takes 3 operands? And there is only one example of an operator which takes 3 operands, and that is this conditional operator, which consists of 2 symbols. One is your question mark and the other one is your colon. And here are the 3 operands. Is this fine? Is this okay with everyone? So,
yes, sir.
All right, fine. So basically, we finish with one section of your chapter, right? What I'm going to do during these puja vacations is I'm also going to systematically write it for you as what are the concepts that we have covered so far. And all of this I'm going to publish in your Google Classroom. I will share the links of all the YouTube classes also on the Google Classroom, so you will get notifications if you are using your Google Classroom. So you will get your notifications, right? And you can go and check, and I will list down all the concepts that we have covered so far. That will also help the students who have just come in, and also for those students who have missed few classes, and probably if you are studying and you want to revise and you want to relook at stuff, then you can also go through those videos. Okay, so since we have some time, and I just want to take a small concept, and then we can finish off the class and go for the vacation. I just want to share a little bit of information about data types and talk something about the data modifiers. Okay, so all of us.
One question. So one question.
Yes.
So
Yes.
conditional operator is also called one single line statement.
I'm sorry. Can you repeat that? Can?
Sir, conditional operator is also called a single line statement.
A single line. That's a single line statement. Yes. Yes, that's right. We can. That's a single line operator. Single line statement. Okay, that's all we're doing it in one line. So that's single line. That's fine. Okay. So what we are doing right now, I'll just touch upon this concept and then we will leave today's class. I will tell you a little bit about, so you have learned the data types, right? You have learned the data types about character, integer, float, and double, right? These are the 4 keywords and these are the 4 data types that we have touched upon, right? Now, what you will learn is that there are 4 data modifiers. Okay, there are 4 data modifiers. What exactly are these modifiers? Now, these data modifiers will enable you to have greater control over these data. Okay, now these data modifiers are basically, those 4 data modifiers are basically signed. Now these are also keyword. Okay, just remember these are also keyword. Unsigned, short, and long. Okay, these are the 4 data modifiers that we will be looking at it. Now, what exactly is a signed modifier? What is a signed modifier? What happens is, it's very easy for us to, if you're doing maths, or if you're going to represent a negative number, it's very easy for us to write a negative sign, right? So if you have a number, say 56, in order to represent it as a positive number, we can just write 56. But if we have to represent this as a negative number, we just put a minus sign there. Now this minus is easy for us to understand, okay? But when we are going to represent a minus number, so what happens is, normally what happens is when you, how does the computer store all these values? The computer understands only zeros and ones, right? Zeros and ones. So it doesn't understand minus sign. It doesn't understand a minus sign, right? Because you can't have like minus along with zeros and ones. All right, so there is a little bit of a challenge in the way the computer understands a minus number. So what happens is, for integers, the leftmost bit can be used as the sign bit. Okay, that means one of the bits, one of the storage bits can be reserved for the sign bits. Okay, now there are, how it's represented into memory, we are not going to worry about it. But if suppose we have this, when we write, like for example, int say 5, or sorry, int a, right, and a is equal to 5. What it means? It means that 5 is a positive number, right? This 5 is nothing but a positive number. But by default, this integers, by default, this integer uses a signed modifier. By default, it uses a signed modifier. That means if you can write these words, these keywords in front of the data types. So if I write signed here, it means that my integer has been modified to store both the positive and the negative numbers. Okay, so if I write unsigned here in the front, that means my integer has been, the structure of my storage has been modified so that it can store only unsigned. Unsigned means only positive numbers. Okay, so how does, so for example, if I have, say, my integer, say, has only 4 bits. Okay, these are 4 bits. Say my integer, that means all the integer, the compiler is allocating 4 bits to store integer values. Now if I write unsigned, this is just an example, okay, because 4 bits are not used to store the integer values. You minimum have 2 bytes, which is equal to 16 bits. So this is just an example. So if I write integer a, that means all the 4 bits are used to store the number. Are you getting it? So the maximum number, the amount, the value that I can store will be 1111 in binary. Okay, but this will not store your negative value. That means only the positive values you can store. So a is equal to 5 will work. Okay, but if I write unsigned, sorry, signed, that means this structure will change now. This structure will change, and the first bit, this one bit will be reserved. It will be reserved. You cannot store the value here, but this will be reserved for your sign. That means the negative. So you can, this will be reserved for either negative or positive. So this bit will be reserved. So what is going to happen? Only 3 bits will be available for you to store the number. All right, so maximum number you can store will be 111. So earlier we could store the maximum values 1111, but because we have made it signed, now we can store a maximum value of 111. However, the range becomes from positive to minus. So if I was able to store earlier, so if I was able to store values from 0 to say 50, okay, if I write signed modifier, that means now 1 bit is reserved for your negative and positive sign. So you will not be able to store from 0 to 50, but you will be able to store from 0 to say 24, and this side again say minus 25 to plus 24. Okay, so this will become your range. That means now your values will not be 50, but you can store, from minus 25 to plus 24. If I remove this signed and make it unsigned, by default it is unsigned. Okay. sorry, by default integer uses signed by default. So if you don't specify anything, it means it is signed. Okay, so the range will be this. So if I don't want negative numbers, then I can write unsigned. So what will happen is the range or my maximum value which I can store will increase. So suppose I'm using something like age. So suppose I am using a variable age. Okay, so I know that age should not be a negative number, right? You cannot have a person with age -3. However, if I don't write anything, by default it is signed. So if somebody enters the value -6, then the system will accept it. But obviously there will be a mistake here because -6 cannot be an age. So just to make sure that we don't enter the incorrect value, right? It's safer to put unsigned here. So if I put unsigned, then I cannot enter -6. It will only take positive numbers. Okay, so there are these two signed and unsigned data modifiers by which you can alter the way the numbers are stored, whether you want the sign plus and minus numbers both to be stored, or you want only the positive numbers to be stored. So if you are using only positive numbers, for example, the price, right? What is the cost of a product? The cost of the product will be a floating point number, say 30.6. But you know that it will not be -30.6. So it is better that we write unsigned float A. Okay. But if there are some applications where negative numbers will be utilized or will be used, then you can remove this unsigned and write signed. Okay, so for default for integers it is signed. Did you understand what is the significance of signed and unsigned keywords? Did you understand, all of you?
Yes, sir.
Okay, fine. Now the other one is short and long. All right, now short and long are again used in front of data types. So you can write short and you can write long here. What it does is it will actually alter the size of your storage. Okay, for example, if your integer gives you a size of say 32 bits, or let's say size of 4 bytes. Suppose your compiler is giving you 4 bytes of storage for an integer. Okay, so this is your 4 bytes. But suppose you are using values for this integer. So suppose if I write int a, right, age. Now we know that age is basically a number which, what is the value of this age, that maximum value of this age? Probably you can have 100, or if somebody lives more than 100, maximum 120. Isn't it? So you can store maximum value of 120 here. So this 120 will get occupied in only a small part of the storage. So 120, and all this storage is actually getting wasted. It's getting wasted, right? So the integer is giving you this much of storage. That means 4 bytes of storage. But the maximum value that you will ever have in this program is 120, and that will only occupy this part, this much of your storage. So if you look at it, the maximum amount of storage in the memory is getting wasted. So in order to save this much of memory, what you can do is you can reduce the size of this integer by half. So what I do is I write this short int. That means integer, whatever value, whatever storage that this integer data types, integer data type, you know, is given by the whatever value of our storage is given by the compiler. By writing this short, that storage capacity is reduced by half. So if your compiler is allocating 4 bytes for integer, if you write short, it will get reduced to 2 bytes by half. Which makes sense, because if I have a number which is only, I know the range of the number, or the largest number that can actually have fit into that variable is going to be a small value. So why should I waste all these, this much of memory? So I don't have a control over how much memory compiler can allocate, but yes, I have a little bit of control wherein I can actually reduce it by half or increase it by double. So if I have an integer value, which I know that integer value is going to be a large integer value. So if suppose I have, this is the default storage for an integer. And if for some instance you're working on some kind of mathematical application, then you know the integer value will not fit into my 4 bytes and it will extend little bit more. So I will need to expand the storage something. Okay, now in order to increase the storage by double, we will use something called as long. Okay, so long and short are two different data modifiers by which you can alter the size of your default memory storage for that data type. So if the default data type for integer is 4, the long will make it to 8 bytes and the short will change it to 2 bytes. The same thing is applicable for your floating point numbers also. So just remember that short and long will give you the flexibility to alter the default size of your data type. Long multiplies it by 2, makes it double. Short, reduces it by half. Similarly, signed and unsigned are two data modifiers by which you can alter the structure of your storage to accommodate a negative number or a positive number. Okay, so there are 4 data modifiers: signed, unsigned, short, and long. These are all keywords in C. That means you cannot use these to declare a variable. So I can't do int long is equal to 5. Not allowed, because long is a keyword. Okay, short, long, unsigned, signed are keywords. So you cannot use to name your variables. Is this clear? Did you all understand?
Yes, sir.
Okay,
Yes.
so this is important because today we have learned 4 things. So just look at these. Char, it's a keyword. Int is a keyword. Float is a keyword. Double is a keyword. Again, these 4 words which I'm writing: unsigned, this is also a keyword. Signed is also a keyword. Short is a keyword. Long is a keyword. These 4 can be used alongside these 4 data types. Okay, so you can also have a scenario where I can write this. Suppose I have an int a, so by default it will say allocate 2 bytes. Okay, say by default the compiler is allocating 2 bytes. Now I can write long. So what happens when I write long? This allocation changes to 4 bytes. Now I can also write unsigned, unsigned. So I can use both these, I can use both these data modifiers. So now what happens is, this entire line, if you notice, I have an integer. The name of that, the integer variable is a. That means by default it would have given a space 2 bytes, but now I have changed it, made it long. That means the size changes and now it is double, right? Okay, and now I have used unsigned, right? That means the structure of this will be such that no place will be reserved for a negative number. So this entire, all the bits which are there inside the memory can be used to store the number, because by default this number will be positive. But if I change it to signed, that means again this is going to be 4 bytes, but because I've written signed, one of the bits is going to be reserved. So you cannot store a number here because this will be used to denote the sign, either positive or negative. Okay, so these are the 4 things that you must remember, because that's all that is there. Data modifiers. Now, importance of data modifiers are because they can give you a greater control of how you can change the size of a data type. Now, sometimes what happens is integer will not work with the default memory, because sometimes your program may give you an output of an integer value which will be more than what is actually allocated. So you should have some flexibility in changing the size. So the data modifiers give you that flexibility of changing the size. Okay, so I hope all of you have understood this, because this is quite important. Okay, and this is all that you must remember. So if you're writing a program, you know, the good programmer versus a not so good programmer. So how can you become an expert programmer? Now the expert programmer, see, you can get the answer. So I can write signed long int a, and I can also write int a, and I can get the answer to a program, and the answer will be the same. But if you want to be a good programmer, and if you want to have an edge over the others, and if you want to go to an industry, and if you want to work there as a very professional programmer, you will have to look at the other aspects of programming. That means, how effectively are you utilizing your memory? How fast is your code? You know, memory is very, very important, because just imagine an application when you're using your mobile phone, right? The memory there is a limited amount of RAM that you can get. Nowadays you're getting, you know, for example, RAM of 12 GB also, right? You can have mobile phones of 12 GB RAM. So the RAM size is increasing over a period of, you know, time, but still there is an issue. So if your program, you know, occupies less memory, if your program runs, you know, when it goes to the processor and it is processing, and if your size of your program is small, that means the instructions are small, that the data, you know, basically the storage and all that you are using in your program is of smaller size, then your program is more effective. Okay, it will be faster. So along with, you know, kind of writing a program, you'll also have to look into the aspects of how to write a better code, how to make an efficient code, how to write a code which is optimized. So by looking at this, so for example, if you have a variable like int a, and a, if you're going to store age, right, if you're going to store age, so you should not be using long, you should not be using sign, you should not be using these two at all. All right. In fact, what I should be using is, in place of signed and long, I should be using short and unsigned. Right? Because all the age values will be a positive number. So I don't need to worry about the sign. I don't need to worry about the negative sign. So let it all be a positive number. And second thing is, because it is age, I know the maximum value will be around 120. That is also very rare, but 120, a person can live at the max for 120 years. So obviously, you know, we don't need an integer of 2 bytes also. We can, let's reduce it. So I don't need an integer of 4 bytes. So I'll change it into 2 bytes by writing short here. Right? Now I have saved half of the memory. So that means 2 bytes of memory I'm saving in my program. Now you will have to think about all these things. Fundamental, these are your fundamental programming concepts. So before you program, you have to analyze your requirements, you have to analyze the kind of data that you're going to use in your program. What will be the highest value of the data? What should be the highest value? Will that data have a negative sign? And accordingly, we have to use these data types and also associate the various data modifiers along with it. And only then you can, so if you have a program with this, then anybody who is going to look at code will get impressed by you, because there is no need to write these such a long statement. You can just write int age and carry on with your program. But this and this will give you the same output. But if you write this, person who is looking at your program will know that you are knowledgeable. They will know that you are a better programmer. Okay. So everybody is okay with what I am, you know, saying? Did you understand what is the importance of using these data modifiers?
Yes,
Right?
sir.
Yes, sir.
Okay.
Yes,
So
sir.
what we'll do
Sir,
is,
having just a query.
yes,
Sir, if we alter the positioning of a header files in a particular program, so is there any issue?
alter the position of the header file. Like, give me an
Let's
example.
let's
Give me
suppose,
an
ma'am,
example.
we're just writing, let's hashtag include, then conio, then after upper
No,
part
no,
we
no,
written the
no, no,
standard
no, no,
input
no,
output.
no, no problem. No problem. You can change. You can write stdio.h as the third one, and you can write conio.h as the first one. No problem.
Okay.
Okay.
Sir, another part. So let's suppose first we declare main function. Just in case if I write a particular code and at the end if I declare main function, so is there any issue?
Particular code means what kind of code? You
Let's
need
suppose
to
I'm
write.
adding.
You need to write a
I'm just
function.
no
You
no
need
no
to write a
in
function.
function. Yeah, Sir, in function I can do it, but in simple code like that, just adding two numbers. In that cases, can I declare the main function in later part?
No, if you're using functions, then you can write the
Ah,
code up and down wherever. But if you're
yes,
not
sir.
using the function, so if you're not
Then
using the
okay.
function, so if
Yes,
you
sir.
have a main method, and inside the main method, if you are not using a function, okay, although
Function.
for all the others who are listening to this, please do not get worried because I have not yet taught you function. Okay, this is, I mean, he has asked a question because he's ahead of the class and he has learned it before. But don't worry about this. I'm just clearing his doubt. If you are not using a function and if you write a code here, this code will not be reachable at all. You cannot reach this code. Okay, so
Okay, sir.
if only you use a function, then only this code is reachable. You can,
Okay,
if you
sir.
make a function call, so if you make a function call here, it will look for the body. That body can be anywhere. You can write, below the main or above the main, the body. Yeah, so it will actually find the body. But if you don't have a function, this code is unreachable because the program will start executing from the main and it will continue here and it will end here. There is no way by which I can go here.
Okay,
Okay.
sir. Okay, sir, got it.
Fine. So I think we should end this class here today. I hope you have understood what I have taught you today.